This slide shows scientific visualization tools that you might find installed on a large HPC cluster. Very briefly, just to name a few of them, VTK is a visualization toolkit library that is a basis of many modern three-dimensional rendering packages. ParaView and Visit are two very popular open source tools for three-dimensional rendering. VMD stands for Visual Molecular Dynamics, and it is meant for visualizing atoms and molecules, perhaps complex biological molecules like proteins, etc. So what we're going to talk about in the rest of this course is learning how to do three-dimensional visualization. So we're interested in a general purpose visualization tool that can visualize pretty much any scientific data that has some spatial distribution. So it could be a single variable, single scalar field, could be a vector field, perhaps a tensor field or something more complex, but it is distributed somehow in three-dimensional space or perhaps in two-dimensional space. It is discretized on some mesh. Perhaps it is a Cartesian mesh or some sort of unstructured mesh in 2D or 3D. Perhaps it's just particle data, a bunch of points in 3D, and then you have some variables defined on top of these points. Perhaps it's polygonal data, some irregular topologies, etc. We want to work with a package that can visualize very large data sets, and by very large, I mean going into multiple gigabytes and even terabytes. And of course, to be able to visualize data of this size, you have to run this package on multiple compute cores, not just on a laptop, but on scaling to hundreds and thousands and tens of thousands of CPU cores. So you have to be able to run this package in parallel on an HPC cluster. You want to have the ability to interact with your data set using GUI tools. Basically, open this package and then load the data set, and then play with it using your keyboard and mouse. Spin it in 3D, zoom in and zoom, turn on and off various variables, apply filters using menus, etc. But also, and this is very important, you want to have the ability to script your data set so that you run it completely off-screen without opening any GUI. And this is useful because you can script your visualization once and then run it many times as a batch job on a compute node on a cluster. You want support for common data formats, and also you want to have the ability to do parallel I/O. So parallel I/O refers to reading or writing the same file from multiple processes at the same time. And parallel I/O is important because if you try to read a, let's say, 100 gigabyte data set, then to read it in serial, it will take you actually quite a long time. It will take you, tens of minutes. Whereas if you do it in parallel using, let's say, 64 processes, it will take only a fraction of a minute. There are two packages that have all these nice properties. One is called Visit. The other one is called ParaView. Both of these were started about 20 years ago. They're very mature. They're open source. They're multi-platform. You can download a precompiled binary for Windows, Mac, Linux, and they're really fantastic. So Visit was developed by the Department of Energy to visualize results of very large simulations. First released almost 20 years ago, and it has all these nice features so you can do different types of plots, three-dimensional rendering, visualize molecules, meshes, slices, etc., etc. It understands over 100 different scientific file formats. It has nice interactive GUI, and it supports Python scripting. It's fully integrated with the visualization toolkit library. And then for parallel data processing and for parallel rendering on HPC clusters, it uses MPI, message passing interface, that we started in the Introduction to HPC course. ParaView is very similar in terms of features. So everything I mentioned on the previous slide applies to ParaView as well. So one big difference is ParaView was developed by the same folks who wrote the VTK library. So there is really tight integration between VTK and ParaView. And essentially everything you can do with C++ or Python code inside VTK, you can visualize in ParaView. So essentially think of ParaView as a GUI interface on top of the VTK library. So why did we choose ParaView for this course? Well, we had to choose one, either ParaView or Visit. So both are very powerful, but they are very different. Their interfaces are very different. The way they process data is very different. So it does not make any sense to teach both Visit and ParaView in a single workshop, because if you are used to one of them, when you try to use the other, you'll be very confused, and vice versa. I personally prefer ParaView interface a little bit more than the Visit interface, but you can easily switch between these two. They're both really capable packages. So we do teach a Visit as well, and we have a number of webinars on various Visit features. So for that, please hit our training materials website. I want to mention a few add-on projects in ParaView, and these are really great because they expand the capabilities of ParaView. So ParaView Web is a JavaScript library to write web applications. You open them in your web browser, and then this web application will talk to a remote ParaView server. So the idea is that you can interact with your visualization inside a web browser, and then all heavy data processing and rendering will be done by a remote ParaView server, perhaps by a big memory server or by a server running on an HPC cluster in parallel. So when you're working with this web page visualization in the web browser, you have a full impression that you're editing a local data set, but in fact the data set is actually being processed and rendered remotely by a powerful machine. VTK.js is similar to ParaView Web in a sense. It's a JavaScript library, but VTK.js does not use a remote ParaView server. So VTK.js is the implementation of the VTK library in JavaScript. So you can use VTK.js to write a website into which you can load a visualization, and then because all rendering and data processing will be happening in JavaScript right inside your browser, you can only visualize, well, up to medium-sized data sets using VTK.js. But VTK.js is really a lot of fun to play with, and I highly encourage you to take a look at it, because it actually lets you load fairly complex scientific data sets and visualize them right inside your web browser. Catalyst is an open source in situ visualization library that can do two things. One, it can help you reduce the I/O footprint of your simulation. When you run a large numerical simulation, it is much easier to compute things than to store them on disk. So I/O, writing data to disk, is a huge bottleneck in simulations. In any large, let's say, time-dependent simulation, for example, doing galaxy formation or fluid dynamics or molecular dynamics, it can produce data much faster than you can write this data to disk. So if you are writing every single time step, all variables from every single time step to disk, then your simulation will be completely dominated by this I/O. What people do in practice, instead of storing every time step, they store every 10th or every 100th time step. But of course, when you create a visualization, let's say a movie from the simulation using every 100th time step, it's not going to look as nice as if you had data at each time step. So what Catalyst library can do is you can modify your simulation code to output only things, only data that you need to create your visualization. For example, let's say you know in advance that all you're going to plot is isosurfaces of, let's say, temperature and nothing else. So you can output only data that is required to render temperature isosurfaces, but not the full three-dimensional distribution of temperature. And this data is much smaller, and you can afford to write it at every single time step. The other thing that Catalyst does, you can insert special Catalyst functions inside your code, and then while the code is running, you can connect to this code from a ParaView client on your laptop. So this way you can actually visualize live what is happening in the simulation as it is running, and you can steer your simulation as well. You can modify your simulation at runtime, which can be useful for some workflows. Finally, ParaView Cinema can be used for interactive visualization of very large data sets. As I mentioned before, very large data sets can take a very long time to render because we are dealing with files that can be tens or hundreds of gigabytes. And rendering a single frame from such a data set can take many minutes. And if you try to load this data set into ParaView and try to interact with it live, you will see that everything will become very slow, because when you try to spin a data set, it'll take many minutes to render the next frame. So it's not going to be interactive at all. The idea in ParaView Cinema is you can pre-render a large number of images in advance. Typically, you know that, let's say you want to take a look at a certain scene and then you want to spin it, let's say, around the vertical axis in 3D. So you render, let's say, 1,000 images that correspond to different angles in this rotation. And then you can do the same for various fields, turn on and off. You can do, other things. But basically, create thousands of images, typically with batch jobs, non-interactively, in parallel on HPC cluster. And then you store them in a special format, in a special database. And then you load the database into the ParaView Cinema web application. And then you can interact with these pre-rendered images as if you were doing live visualization.